All right, looks like we're live. Thank you everyone for joining our first ever interactive webinar. And because it's our first one, please bear with us as we go through this really interesting webinar features here with On24. It's interactive, so feel free to ask away, ask some questions, check out some resources, check out the speaker bios. Saeid, our first presenter here, has long bios. You're going to definitely want to listen into him and obviously follow up with him because he's going to have some really good information here that we're going to try to tuck into it under an hour here. Feel free to engage. You can register for more of these events too at the end of the show. And you can even book a meeting with us or Saeid, I believe. Saeid, you can book here as well too. Anyways, bear with us. We're going to go through this. I believe most people are here now. Looks like we got a few people still straggling along, but we're going to get on with this anyways because this is recorded. You're going to be able to click on the links on our YouTube channel to see the webinar and also to share the webinar because even though it's interactive now, it's still interactive afterwards as well. So people can actually watch this webinar and actually ask questions to myself or Saeid and gain lots of insights, even if you aren't here for the live portion. All right, so we're going to get into next. Here we go. A little bit about ourselves. We're Aelius LED. We've been around since 2018. We're a global LED light provider. Our main focus was in the cannabis area, but now we are approaching guys like Saeid and institutions, schools, in order to get into the vertical and greenhouse farming of food and focusing on fruit and veggies. The cannabis world brought us a lot of premium lights, and we are just taking that to the next level, and we find that the fruit and veggie world is going to be much, much better. That being said, our presenter that we're going to come up with here is Saeid, and we are going to begin with the next slide. There we go. Okay. All right. So this is going to be about 45 minutes, 15 minutes of Q&A. We're going to start with my introduction. I'm going to introduce Saeid a little bit, and we're going to get into the harnessing of horticultural lighting for optimal growth presentation that Saeid put together himself. And again, like I said, there's engagement, participation, Q&As, polls, surveys. Feel free to answer them. Resources, you can click on some links. And again, like I said, you can register for the next presentations. All right, Saeid, like I said, here's Saeid's bios. Saeid's been in this industry for a long time. He's currently the Phytotron Research Facility Manager at Queen's University. He has his own consulting firm as well, too. He's got 35 plus years of experience in CAE, which is a terminology and acronym you're going to hear a lot during this presentation and probably in the decades to come, because controlled environment agriculture is going to be probably one of the reasons why our food is going to be secured down the road. Saeid, I'm going to, the same thing with Saeid. This is the first time you're doing this as well too. So if you ever do get stuck with some of these slides, feel free to just chime in and I'll help you along, okay?
Sure.
All right, let's go next. So what you're gonna learn a little bit about lighting. You're gonna learn about light quality and spectrum. We're going to optimize light intensity with Saeid. He's going to talk about the LED efficiency and some sustainability, enhancing produce quality, and smart energy management. Saeid, the table is yours.
Thank you, Ryan. And I should say good morning, good afternoon, good evening for everyone. And thank you for joining today's webinar. This is Saeid, and I'm pleasure to talk about my passion today. I'm very excited because horticultural lighting is something that every day I'm learning something more and more, and it's never ended to learn from the horticultural lighting. And obviously, this is a very good opportunity to understand what is the good area and what is the right information about horticultural lighting. So today, we will be exploring the crucial role of the horticultural lighting in optimizing plant growth. We will discuss how advanced lighting strategies and including customizable LED spectra and enhanced plant health can enhance plant health and yield and overall efficiency in control environment, how we can reach to that. Let's dive in. So obviously, light is essential for plant development and influencing on the growth, morphology, and overall health. Plants convert light energy into the chemical energy, producing food and oxygen through the photosynthesis process. Proper lighting enhances plant productivity, improving yield, quality, and efficiency in control environment, or CEA. Light quality. We know that red light is the most important part of the spectrum that promote photosynthesis and is essential for stem elongation, flowering, and biomass production. But at the same time, blue light also enhances leaf expansion and chlorophyll production. So you can see the more chlorophyll and the more green plant with under blue light, and leading to the stronger and more compact plant. So it's also a stimulator of some production of the secondary metabolites, which can improve the plant health and nutritional value. At the end of this slide, you can see around the 650 we have or 670 we have a red, but after that we have a forest. Forest is recently came to the play, and the researcher found that in the last like 5-6 years that it's very important to impact on the flowering and biomass accumulation. Although we know about the forest and the red to forest ratio about effective on the shade avoidance and the plant elongation for a few decades. So behind the plant morphology, light spectra can do effect on the nutrition content and the shelf life. For example, a specific wavelength can enhance antioxidant levels and vitamins. They can produce specific pigments, leading to higher quality produce with the extended freshness. Let's go to the light intensity. So in addition to the light quality, light intensity and distribution are critical factors in optimizing plant growth. Remember, every time, all the time, we have to look at the light with the three parameters at the same time: light quality, light intensity, and light distribution, and plus the photo period. So we cannot just talk about the light spectrum without the light intensity, or just focus on the PAR or PPFD without looking at the spectra. So it's completely making a wrong assumption. So for making a good assessment of the light intensity, we need to good understanding of the photosynthetically active radiation, or PAR. And recently, we are talking about the extended PAR, or EPAR, that even behind the 400 to 700 nanometers. So we are starting from 380, that's cover some UVC, up to 770, that is cover the forward. So at the same things, PPFD and EPPFD is more valuable rather than the old term of the PPFD.
All right. Quick question here. Quick question here, Saeid.
Sure.
Somebody asked in regards to these light qualities and light intensities. Obviously, different plants require different levels of intensity and different quality.
Absolutely.
Is there obviously the sun is the sun. It has its own intensity and its own quality. In your research, I guess, do you actually play around with this quality and intensity depending on the plant you're growing?
Absolutely. This is exactly what we are here today, because this is something that we can talk in the later slide. You will see how we can do something even better than the sunlight. So sunlight, as you said, is a one package. The sunlight might be different based off the different geographical places, but when you are living in like Ontario, you deal with the sunlight with the one single spectrum. But when we go to the LED light, one of the most advantageous is we can tune and tailor the light spectrum that we can adjust it based off our plant needed. So this is exactly what we are going to talk about. Make sense? Okay, so the last part about the light intensity is a DLI, or daily light integral. So we should understand the DLI and consider that's a very important terms that represent the total amount of light the plant is received in the day, meaning that DLI is critical for the managing and consistent of plant growth, specifically in control environment, because when we pay for energy and produce the photons by the putting electricity, we have to caution there's no free sunlight or free energy. So that's mean that we have to minimize the energy waste. And of course, by optimizing light intensity and distribution, we can enhance plant development while improving energy efficiency. That's a very important point about how we can increase the efficiency. Okay, let's talk about the LED efficiency and sustainability, because this is the most important part nowadays. Of course, LED technology has revolutionized horticultural lighting. I understand like 15 years ago, when I worked with the first horticultural lighting, everybody was not even thinking that how this LED can change the entire agriculture industry. Nowadays, I can see the vertical farm are existing because of the LED lighting, and this offering high efficiency, sustainability, and plant-specific benefits. Compared to the traditional lighting system or HIDs, LEDs provide precise spectral control and energy saving, and a longer shelf life or longer span, and making them ideal for modern agriculture. Without LED, we cannot do the lots of the like a modern enhancement in the vertical farming and some of the greenhouse, particularly in Canada, that we have a very long winter and short days all the time. So if I want to explain a little bit more about how we can get the most benefit of LED, I should just say in terms of the crop yield and quality, LED supports optimal plant growth, leading to higher yield and improve the plant consistency, because this is just something that we cannot do with the sunlight, and everything is related to the different season and different year. We have a different cloudy days, dark days, or very hot days, cold days. But when we stick with the LEDs, we can manage everything very, very accurately. So we have a consistency in the production year round. No effect on the climate and the changes. In terms of the flavor and the nutritional quality, of course, a specific light spectrum, and we are talking about later, can enhance the production of the sugar, antioxidants, vitamins, and improving taste and health of the plant. So we can get the manipulate the plant health, manipulate the plant height, and even nutrition value by having the ability to adjust the spectrum. Of course, it's about the biomass and photosynthesis efficiency. When we talk about the LED, we know that LED drive the target light spectrum because we have a different chlorophyll A, B, C, and different other light receptor from each species to another is different. But when we understand the plant physiology and understand what spectrum required for each plant, we can simply adjust it based off our target. It's a very simple example. Always I started with that example with my students. So let's go back to the 35, 40 years ago when agriculture just started experiencing hydroponics and soilless culture. At that time, everybody has a concern or struggling to how understand all the macro micronutrients. They didn't know about the effect of nitrogen, phosphorus, potassium, calcium, iron, magnesium, and so on. So now everybody knows that all these 16 macro micronutrient element has effect on the each plant. Like you have a fertilizer solution for tomato is completely different than cucumber or peppers or flowers. This is exactly same revolution, shifting from soil to soilless, and now we are shifting from HID and the sunlight to the LED. So we have to spend more on the study and understand all these different spectrum, and then we can simply pick the suitable spectrum for a specific plant. That's a main point. And of course, when you're using the LEDs, we can optimize the flowering and estrus resistance. So by tailoring the lighting strategy, we can promote the flowering or even delay the flowering. We can strengthen the plant defense against the different environmental stress or diseases. So that means that this research should be able to advantage and demonstrate the LED lighting importance. So how we can enhance the plant productivity and sustainability? Yes, by adopting LED solution, and growers can optimize crop performance, and while they can reduce also energy consumption and reduce the environmental impact. I hope it is answer the first question already. Okay, let's go to one of my recent trial that I just harvested last week. So by optimizing light recipe in the, we can keep up the quality of the fresh produce. By optimizing light spectra and intensity, we can enhance the key attributes such as taste, texture, and nutritional value. For example, on this table, you can see I had the NFT nutrition film technology system side by side with the high red and the high blue and the control. So I have a different treatment while this table shows that in my recent trial, I had a high blue with the 25% blue rather than 17 and 19%, and the high red with the light spectrum of the 46% rather than the 37 or 40. So these lighting spectra demonstrate a significant effect on the plant morphology and stress resistance and overall quality. By refining our lighting approach, definitely we can produce healthier and more appealing fresh produce. So as a result, you can see the red dominance spectrum and the blue dominance spectrum that I grew planned in the old statistical analysis comparison was 100% replicable, and we got a very good result because we found that a specific light we can influence the sugar accumulation, firmness of the texture, and the production of vitamins and antioxidant, and this of course leading to improve the flavor and nutritional benefits. On the other hand, I found that comparing to the control, we can reduce or eliminate the tip burn, which is one of the big concern on the lettuce and some of the other leafy green production. Tip burn can manage by adjusting the spectrum and the light intensity. And of course, because when we know the requirement of the plant, we can easily remove the plant ester. So that's another point. So you can see on this slide that's how high blue light produce the compact growth and better calcium uptake and control the tip burn and delay the bolting. So we don't have a bolting on this species, but in the other experiment, I had seen the bolting like in the other crops, but blue light is very helpful on that cases. Of course, we can use the high red light for the larger leaf expansion and the biomass. And by minimizing the far red light, we can prevent the bolting as well. On the other hand, we can increase the far red for the leaf expansion and the taller plant, or depending of the plant species, far red have a different effect. Also, UVC has a combined with the blue light can enhance the leaf color. For example, I had the experiment that by adding the UVC and blue light in the just 48 hours before harvesting, we turned the leaf color from the totally green to the totally purple in just 2 days. Of course, it is not for every crop, but it works with some species. So, okay, now let's talk about the energy management and carbon footprint reduction, because this is very important for our future, our next generation. And I'm person as a biology, we care about the energy management and the carbon footprint more than the yield and the production. But this is very important that if we use the effective energy management, we can use it as a key to improving efficiency and reducing the environmental footprint for modern farming, of course, by integrating smart technology and renewable energy source. We can optimize resources and use this while, of course, maintaining the high crop yield. So without compromising the yield, we can reduce the energy consumption. How we can get to that point? So one of the most approach is using smart lighting control, such as automated lighting system by adjusting intensity and spectrum based off the plant need. In this case, we can reduce energy waste and improving efficiency. Another point is combining and integrated of the green energy to the CEA industry by using the solar, wind, geothermal, or other renewable energy source. We can help to power the vertical farm as a sustainable and future of agriculture, because the vertical farm meet all the requirement of the UN nation and the sustainability of the agriculture and the future. Only restriction or bottleneck still exists currently is energy consumption. If we can do this point, we can minimize the environmental impact, and of course, energy efficient LED play a very important role to combine with this advanced management system to reduce the carbon emission and overall resource consumption. So if we want to go a little bit deeper on the how we can manage the energy, so we can talk about achieving optimal result while maximizing efficiency. So nowadays, dynamic LED light is one of the important part. Of course, automated management system can adjust and reduce all the waste. So we are not running the LED when the plant don't require the light, or even as a supplemental light in the greenhouses. As soon as the sunlight is enough, we can shut down or dim down the LEDs. In the early morning, in the late afternoon, in the sunset and sunrise, we can use this automation management to enhance the plant growth and reduce the loss of the physiological disorder like edema or tip burns and tip burns. Another advantages that we can simply implement in the vertical farming is a little bit challenging in the greenhouse. And of course, it's very hard to predict in the outdoor production is the AI. Smart algorithm can optimize the light condition and ensuring the plant receive the right amount of light at the right time. This is very important because when we talk about the vertical farm, we are 100% independent from outside. There is no outside storm, cloudy days, hot days, cold days, or even different seasons can impact. So AI can easily develop the algorithm and repeat it very easily, much more and accurate than any humans. So I'm a person that working 35 years in the greenhouse. I understand always I have some bias and some like an error to operate my own greenhouse. But AI is a very easy way that for the new generation and the people that have a zero experience on the growing plant to use these tools to grow the plant without any hassle or without any stress. Another important is IoT that is connected all the sensors and the devices with the real-time monitoring, so you can get all this alarm or even the troubleshooting right away by your cell phone, and it's like saving your life and making your life much easier if you wanted to go to the agriculture industry rather than my father and my grandfather that never even sleep on the like a storm night because they worry about their plant. But nowadays everything's on our smartphone and everything is under control with IoT. There are lots of other things like a HVAC system and vapor pressure deficit. So they are also important to saving energy. One point that I should explain here that people always undetermined the HVAC system. So HVAC for heating and ventilation and cooling is a very important part of the operation, either in the greenhouse or very important in the vertical farm. The good news is if you can use the higher efficient LED, even for 5% more efficient or 10% more efficient, you can save the same amount of the energy saving for the HVAC system, because any energy we put for the lighting system, consequently after they convert to the photons and absorbed by the plant or transform to the heat, and we have to collect and remove this heat with the HVAC system. That's a very important point to know. So, Ryan, if you have a time, can I go a little bit about the benefit of the dynamic LED, if people are interested? Because this is the most important part, and if we know this part, we can easily make a lot of the benefit out of that. Because
yeah, no, absolutely. Because like you were mentioning, Saeid, the LED world is basically, we've gotten to a point where a lot of lights are similar. Now we're always stretching for the next best thing, right? And I think part of this comes down to this dynamic LED research that you're doing over at Queens.
Yes, I understand that. I started my first LED trial in 2016, 17, in the Brooks greenhouse research, and at that time, it was very hard to even talk about the DLI. So now everybody knows about the DLI and how we can dimming or tuning the adjustable in LED with the specific intensity and the spectrum is like a next step for the advanced and modern agriculture. So we can enhance the plant growth with the custom light recipe by tailoring spectra for different growth stage. Of course, by optimizing the photoperiod, we can align the light cycle with the natural pattern of the sunlight.
Yeah, and actually, we just got a question on that, Saeid. Somebody just asked, does sunrise and sunset affect DLI? I'll let you explain that.
Yes, effect on the DLI because right now in my background I have a alga system that I put it on the DLI when the plant reached to this certain DLI and I need it. So after that, we don't need the supplemental lighting, and supplemental lighting would be shut down. So, but when we have a sunrise and sunset, they have a very small amount of intensity. So usually when we talk about the sunrise and sunset, it's a two factor. One is the quality of the light in that time is different rather than the noon. So that's not related to the DLI. But when we talk about the light intensity, of course, there are like a minimum light intensity during the day. So if we have it in the higher altitude, like in Canada, we have a very long period of during the sunrise and sunset. So we technically we don't have enough sunlight to run the photosynthesis. But if you in the numbers, you can see the 12 hours of the duration of day, but that 12 hours is not running the photosynthesis because of very small light intensity during the sunset and sunrise, right? So we have to stick with the DLI to give us the actual light intensity that which each plant needs. For example, we know that for a certain plant need a specific DLI. If we are not reaching to that part, that means you are not getting the highest potential of yield of that plant. So, but if you are passing that DLI, that means we waste energy and we not require more light for because the plant cannot use them. It's useless and is wasting, right? And how about another point about with the dynamic LED, we can even reduce the operation costs because all this electricity as maintenance is related to the operation, and all the LEDs have a lifespan based off the hours of operation. So if we run the LEDs in the less hours, of course, you can keep it for the longer period of time and cutting the replacement cost. But if you compare the LEDs with the HIDs, in the HPS or metal halide, we need to change the bulbs every other year, and the ballast need to be changed every 2 years, 3 years, and the whole fixture need to be replaced after 5 years. But when we talk about LED, it is good for the next 10 years minimum. If you have a better quality, you can even hold it for the 15 years. So that's another beauty of the LEDs and how we can reduce the capital cost and operation cost. So another point about the importance of the dynamic LEDs is precising and enhancing the taste, texture, and nutrition, as I mentioned earlier. Of course, when we have a tailored spectrum, we can ensure the healthier and more resilient plant to the pests and diseases. So that's another prevention rather than just waiting until powdery mildew or different fungi or diseases coming here, and then you can struggling with the pests and disease. So we can make a plant more stronger to defend itself and not allow any fungi or pathogens attack your plant. And at the end, but the most important part is another effect of the dynamic is lowering carbon footprint, because decreasing energy consumption and emission is our main goal, and sustainable practices and integrated for the renewable energy is another point. When we have this factor all together, obviously we can get the best benefit of our LED. Usually running the LED, plugging LED and running that is not getting the majority of the benefit of LED. So usually people thinking if we replace the HBS with the LED and plug this one, we are safe. I can tell you, you are getting the 25% of benefit of LED by the replacing, but 75% of the benefit of LED is understanding of how to use that. For example, here, one of the most common questions that I receive usually is how to select the high efficient LEDs. So for specific projects, you need to have a specific LEDs. So there is not single LED for every crop. Right now, we have more than 2,500 LED manufacturers worldwide. Choosing the best option requires more than just looking the advertised efficiency claim. In terms of the manufacturing claim, many brands highlighting high photons flux or high light percentage or high power efficiency or efficacy. But these numbers are simply can be misleading. In terms of energy differences in the spectra, for example, we know that the blue photons require more energy to produce than the red photons, meaning that the higher photons output doesn't always translate to the better plant growth. Even in terms of the limitation of power measurement, power value, even E-power treats all the photons from the 400 to 700 nanometers equally. But in the real world, not all wavelengths contribute equally to the photosynthesis. So we talk about that at the beginning. So that's coming to that point that for the marketing tricks, when you want to go and buy some LED, always you should keep in mind that some sales tricks used to this using these numbers to make a one LED appear superior over than others. Even it is not the best choice for your plant productivity. So that means you should consider everything all together, not just the number that shows on the manufacturing claim.
That's a very good point, Saeid, because a lot of these are just claims.
For saying that, right? Maybe you are not happy with that, but I have to say for everybody that they should know the real situation.
Oh, 100%. We're in that mindset as well, Saeid. At the end of the day, LEDs have come along so far. You mentioned that there's hundreds. I don't know, there's 2,500 manufacturers, but there are a lot of manufacturers out there.
Yes,
so
I know
to find the right one is tough. And not only that, like you said, a lot of them are just claims, and just because they have high efficiency levels doesn't mean it's right for your plant or for your strain.
Even the big companies, like the largest, biggest, highest level LED manufacturer, they have some claims that even not close to the real. So I can tell you, those companies that everybody are heard about this name, they are not. Because they don't have an agriculture background, they don't have an understanding of how to grow plant. They know how to build the fixtures. That's it. But the when you are grower, you want to select the plant, you should understand your plant requirement, not the like LED specification. LED specification in the one things, but most important things is understanding what exactly you need, why you pay for that something that you don't need, or why you pay for something that you need more, or in the later you cannot even change it. Because most trick and the challenge on selecting LEDs is when we purchase the LED, you have to deal with that for next 10 years. If you order the wrong fertilizer, you can simply return them, or you can change your batch. You just waste the 100 liter of water and put the new fertilizer, and you're good to go. But when you put the wrong LED on your farm, there is no way. It's a very pain that you have to spend like 50% of your capital and then put it in the garbage, because nobody can buy it from you, and it's very, very hard to see that this like a frustration with the growers when I talk to them. So that's a very important reason that to improve the education and understand that important of the selection of the LED in the first place.
Yeah, and that comes back down to just do trials on a smaller grow area to see if it actually works for your particular plant.
Exactly.
We're big proponents in that too, because we've seen it firsthand that you can spend hundreds of thousands of dollars and put the wrong efficiency in there, and it's not going to work.
100%.
All right, so we have our first survey here, Saeid. I know you put this together. This requires some participation from our audience here. You want to walk through this?
Yes, let's engage with this structural discussion with our first survey. So we want you to identify the most important environmental factor for optimal plant growth. So please take one of these factors and give us your suggestion for the most important factor for successful cultivation. So
you don't have all the above in there. They all look pretty important. Is there a right answer here, Professor?
But there are some. I picked the most important part, but there are some more rather than others. So this is selected exactly to help us to understand better the key priority in environmental management and how different factors influence plant growth and productivity. So I'm waiting here to see what is the response of our audience. Then we can see the results.
Yeah, we're going to start seeing the results here soon. That is a good question. Where are these results? While we're waiting for the results, we have a lot of people that are interested in the DLI aspect of plants. And I'm sure that has to do with, DLI, daily light integral. People are becoming more and more educated. And that's exactly what this series is for, right? And with this education becomes more questions. So this daily light integral is becoming really important. You want to go through that while we wait for these questions here and explain what daily light integral is?
Absolutely. I show you in the first slide today, when I was holding the DLI meter on my hand on the 15 feet height on the scissor lift. So I was working with the larger high wire crop, and we had 14 different DLI meters and to collect the DLI per day. And we run this experiment for 2 years with a very large scale operation in the high wires. So what you can see the DLI. So let's say, make a very simple example. So if you are growers, you wanted to go to your field and start irrigation. But before you start watering your plant, you want to see the weather forecast and how much rain you get in the last few days. So, for example, yesterday you have a lot of the rain, so you can go to your data. You can see like a 5 millimeter of rain you had yesterday, and your target was 10 millimeter watering today. So that means you don't need to put the 10 millimeter water today for the whole your farm. You need to just top it up with another 5 millimeters to keep the requirement of water for your plant. It's the same things for DLI. So the total amount of photons that the plant or receive per square meter per day. That's why we're not using micromole, we're using mole. That's because a huge amount of the photons. So that means when you run the supplemental lighting today, you know yesterday how much DLI you got. So according to the DLI data you have in the previous day, you can adjust your light integral for today, rather than just guessing that today we wanted to get the DLI of 20, but if yesterday you already have like a 10 DLI from sunlight, you need to add just another 10 DLI from your supplemental lighting to meet the plan requirement.
Gotcha.
Is that?
All right, so we got the poll results in, Saeed.
Awesome.
Well, look at this. You can tell this is everyone's going towards the lights, light intensity, light quality. What are you seeing? Are you seeing the results here, Saeed?
I do. Yes, that's exactly what I was expecting, because the light intensity, light quality, and photo period. Because if we have a good intensity and quality, with a short period of time, we cannot reach to that DLI. So photo period also important. Let us find that some plants are daylight sensitive, like you have a short plant and a long day plant, short day plant, and that's so this is three factors: light intensity, light quality, and photo period is the most important factors for the successful cultivation.
All right, and then your next one is, what would you say is the least important for successful cultivation? Least important, eh?
Yeah.
All right. Let's see what else. What other questions we have here? So those are the DLI questions. Somebody asked, when it comes to lettuce, is there a recommended sunrise, sunset, and DLI that you recommend? And I guess not just for lettuce, it could be for any crop, right? Is there somewhere people can actually go to that is reliable, as opposed to just asking ChatGPT?
Of course, Dr. Google and ChatGPT is good for the very, very elementary or beginner that have no clue, no idea about the a specific topic. So it's good just for understanding what you are standing. But if you want to be successful, if you want to grow professionally, if you are care about your money invested and wasting energy or wasting your time, it is not recommended to just trust the ChatGPT or Dr. Google or YouTube. So always all the doors is open. Myself and so many different scientists I know on the world that they're providing the accurate information, and please reach out, and we are always open to help the people and provide the suitable solution, because this is not one single solution for everything. And for example, for this question for lettuce, so I can tell you very, very generally, so lettuce need a DLI of 12, but as I mentioned earlier, this DLI and even PAR and EPAR is just making equal evaluation of all photons, but we understand the photons of the UV, C, and the blue and red and green and far are not equal. That means you need to dig into that and talk with the expert, other than just rely on the ChatGPT and even textbook, because textbook that we have is behind, very behind. Yeah. The best publication I can see right now on the data is in 2024, but in the last 2 months we are in the 25. We have lots of achievement and enhancement on the lighting. So if you wanted to go to the textbook or literature, always you push yourself to the 5 years back from the advanced technology that right now is available to you. Right?
Makes sense. Absolutely.
Okay, let's go to
so people believe this, the growing media is the least important for successful cultivation. Saeid, is there a right answer for this poll?
Absolutely, because when I started my greenhouse 35 years ago, my own greenhouse, I started with soil. And I grow a couple of different cut flowers, vegetables in the soil, and started challenging with different pests and diseases, some soil burn diseases, and even nematodes, lots of the headaches. So after 5 years, I stopped working with the soil and shift to soilless. And now I can see that even the aeroponics doesn't need any growing media. So if we shift from the hydroponics to aeroponics, you are completely free from any challenges that you are struggling and even cost of the growing media. So you will have a completely like a peace of mind rather than dealing with so many different challenges on the growing media.
Gotcha. All right. So, whoops. Sorry. What's the next one? Considering the following, which would you expect to require the least cost and energy to manage or control? The least cost to manage and energy to manage and control.
Yes. There are same parameters. We are not changing parameters. Everything is the same. But now we wanted to ask you, in order to expect the cost and energy required to managing and control. For example, we can put the more important, most cost or most expensive parameters and most energy consuming parameters, and the most cost effective or most efficient parameters to do your cultivation. This is also very important question, because this exercise will help us to identify the key factor that drive operational costs and energy use. And it can allow us for better decision making in optimizing CEA industry and farms.
All right.
Okay, perfect. Thank you for
so they want the growing media again.
Okay, so it's not coming yet?
Yep. Do you see it now?
So you can see the growing media and relative humidity, light intensity, water period, macro, micronutrients. Okay, not bad. So you can see as we just talked about, if you can remove the growing media, you can reduce the big hassle and the big operation costs on your farm, but just a good designing of your growing system. So it's a good solution, obviously. And
Gotcha.
Relative humidity, it's very, very challenging. Running the dehumidifier in the vertical farm or the so many greenhouses is a big headache and consume lots of the energy, and plus producing lots of heat. And another problem is temperature management. After you reduce the humidity, you have to deal with the temperature. Good.
Okay, good. Next up, what do we got here? We are going to. We're running at it. We get kicked out here at 2:15, Saeed. So we're going to skip a couple of these other polls. I really want to get to some of these question and answers,
That's
but I want
fine,
you to
yes.
finish. I want you to finish your presentation here.
Of course, of course. So let's move on to the some tips and tricks that for optimizing the plant growth under the artificial light. Here is a few key points for the to keep in mind. So first, as Ryan already mentioned, start with the baseline. Begin with the, using a full spectrum light, which provide the balanced range with the wavelength, and from there, observe how your plant responds to the making a spectrum adjustment accordingly. Don't just jump to the one tunable, dimmable LED and mess up. So this is like a very challenging part. So I recommend it to start with some experiment and play with your plant, even the different growing stage of the and different species need a different spectrum. Testing in different spectra will help you to determine the most effective life recipe for your specific crop. That's something that I'm doing in the last 14 years, and still I'm learning a lot from this point. And of course, seek expert advice. While manufacturing provide the general guidelines, they recommended may not always be tailored to your specific condition, because they cannot even understand what your crop and your growing condition is. Instead, consult with the horticultural specialists and the scientists that have a good knowledge and experiment in the horticultural lighting to ensure you're making the best decision for your setup. And my takeaway slide is, as we wrap up here, the key takeaway from this discussion for horticultural lighting. First, it's horticultural lighting is essential for plant growth and health, and improving both yield and quality. Of course, proper lighting plays a crucial role in optimizing plant development, and specifically in the control environment, because we are able to manage everything by our own. The second is customizable LED spectra. In the near future, I can see this allow us to target a specific plant response by adjusting wavelength, such as UVC, red, blue, green, far red, and red. We can enhance plant growth, flowering, and performance. And third is a different light spectrum have a distinct impact. By understanding of plant morphology, we can adjust the yield, quality, and help us. We can help to improve on the decision and optimizing the plant production and the operation of farm very accurate. And least but most important part, efficient LEDs, if selected in the right way, can tailor the light solution and enable growers to maximize growing while reducing the operational costs. By finding fine-tuned lighting system, you can improve your productivity and sustainability in indoor and greenhouse farm farming. And that's it. My last slide.
That's fantastic, Saeed, and we'll get to some questions and answers here. And I thank you for doing this. I know, well, I guess you're used to doing presentations as a professor over at Queen's, but over the past couple of years here, we've really relied on some of your insights and some of your work. And like you said, it really pays to actually ask those important questions and get the proper people to give you those answers. So much appreciated. All right, let's get to some questions here. Well, we're talking about DLI again, but proper DLI with the wrong VPD is a waste of electricity. Make sense?
When we talk about the VPD, vapor pressure deficit, so that's a combination. Like me to give you another simplified example. Plants don't care about the temperature. Plants don't care about the humidity. So why we are measuring the temperature and humidity all the time? Because we are not able to measure the VPD. We are estimating VPD or calculating VPD based off the temperature and humidity, plus air velocity. So VPD is something that plant care to for the stomata conductance, opening and closing stomata. And this is again coming to my first slide for the photosynthesis reaction. We need to give the carbon dioxide to the photosynthesis. So if the stomata is closed, plant cannot absorb the CO2, cannot release the oxygen. So photosynthesis reaction will be suppressed or stopped. So VPD controlling that part. But the light or DLI, let's say forget about the DLI, because DLI is just for maximizing the yield. As soon as you put enough light to the plant, the first thing that is effect of your plant, even some people thinking plant is not response that quickly, like a second, even half a second, plant can respond very quickly with the light. As soon as the light you're starting, stomata start opening. When the light's gone, dark period stomata start closing. So plant responds very, very fast, but you cannot see by your eyes. And that's the effect also on the photosynthesis reaction. Of course, we need the light for the photosynthesis, but because energy, but stomata also responds with the light in and out. But these things, let's not combine these things because this make it more challenging. You can reach me to later, and I can explain specifically. But let's put it in the separate to not making confusing.
Okay, I got another one here. Is it possible with hydroponic growing to have Brix levels above 8 to 10? My interest is for insect control.
Brix level? Do you need the Brix? What?
Yeah, he said BRIX levels.
So if I understand Brix, because we have a Brix item for the making a measurement of the sugar content.
Yeah, yeah, that's what
we have a Brix for the like a strawberry, but it's nothing to do with the pest and diseases. So if you can explain your question better, I hope that I can answer your question.
Is it possible for hydroponic growing to have maybe they're trying to find out, is it possible for hydroponic growing to have Brix levels above 8 to 10? Are some crops, do some crops you want more than 8 to 10 as far as the level goes? And maybe outside you can get there, but inside you can't. Well, we have the person who asked that question. We'll get more details on that, and we'll fire it off to you.
If it's Brix about the strawberry, I can tell you these numbers, but if it's Brix for the other crops, obviously I don't want to give you some confusion answer.
So what's the Brix for a strawberry?
So I can tell you, usually the Brix that you can get in the Mother of Nature, in the best part of the world is California. That has a well-known place for the agriculture in the world. Most of the strawberry we eat in North America coming from California, and some of them are coming from Florida because they have a huge amount of sunlight. But the Brix that you can get, the maximum is a 6 and 7%. Gotcha. The Brix you can get from greenhouses here in Canada or US, it's about 4 to 5. That's why the sugar content is very low. And when you eat a strawberry from greenhouse, you feel nothing. You cannot even feel the flavor of the strawberry. But I can tell you, and I tested by myself, by using the vertical farm and indoor farm that we completely secure from the outside, reach to the Brix of the 14 13 and 14. This is a completely like a blowing mind, because nobody even imagined that strawberry can be that much of the flavor and sweet because of the, again, the vertical farming and LED lighting.
Okay, gotcha. And there's a couple questions here as well too. And if we don't get to your questions, everyone, don't worry. We'll get your answers, or you can actually just reach out to myself or Saeid in the at the bottom there, where it says bios. So there's a couple people that were wondering about, for instance, how is growing strawberries different than leafy greens using hydroponics and vertical farms instead of greenhouses? And we had another one too asking what the difference is between vertical farms and greenhouses. And obviously you came prepared because you have a slide for that. Let me push that up.
Yes.
There you go.
I put this one because this is a very common question. Actually, I present this slide in Germany when I working for the International Association of Vertical Farming and Vertifarm projects in Germany. So it's a very common question that you can see the greenhouse always needed more land and more labor cost, but obviously greenhouse has a less capital cost for the starting. But in the vertical farm, we need a lot of infrastructure like LED, HVAC, racking, so that's making more expensive in at the beginning. But the point is, you cannot compare the 1 acre of the greenhouse or with the 1 acre of vertical farming. Is apple to orange. If you want to compare apple to apple, I can tell you, we designed vertical farming. I have designed it in the several occasions here in Canada, that 1 acre of the vertical farm can produce equal to 55 acres of the greenhouse. So if you want to compare the capital investment of the 55 acre of greenhouse with the 1 acre of the vertical farm, that's a fair comparison. And about the light, of course, you get the supplemental lighting for minimum of 5 or usually it's more than 7 months per year in Canada in the greenhouse, because obviously based off the DLI map that I produced for the first time for the Canadian in the 5 years ago, we didn't have a DLI map for Canada. So we concluded based off the 29 years data that every single greenhouses in Canada need a minimum 5 months supplemental lighting. That means even you cannot rely on the sunlight for the growing plant. So when you have to purchase the LED and put it in the supplemental lighting to make it absorb the free energy from sunlight, you have to accept the lots of challenge in the very cold winters and the very hot days in the summer, that because you cannot making insulation like a vertical farm. When we have a vertical farm, we have 100% independent, and we don't care what's going on outside. So that's another advantage about the lighting. Yes, you can spend more energy at the beginning, but if you select the right HVAC, right LED, and right system, you feel for the next 10 years or 15 years. Again, compare 55 acres greenhouse with the 1 acre vertical farm. Is it sufficient? I can go with the other slide if you wanted to talk about.
This is good. And like I said, if people are more interested in some of the stuff that you touched upon today, it's going to be up there on our social media platforms, YouTube. I'm sure that you don't mind sharing this presentation with people either, Saeid? Yeah. So what we can do.
Yes.
Yeah. They'll reach
my
out
email
to you
address is very simple: hello@innofarm@gmail.com. You can feel free to email me, and happy to share with you and answer any question.
Yeah, and Saeid, like I mentioned earlier, this is great, and we've had a great relationship over the past couple of years, and we appreciate everything that you've done with us, and we look forward to continuing this working relationship for decades, right? Just as long as our lights last.
My pleasure.
All right, so next up, we got some more. As I said, this was our first one, so thank you for bearing with us. Do join us for more series, as we have a couple more next week. Coming up, we have hydroponics for a greener Canada with Mackenzie Warford and Cindy Rice. They are the starting members of CHAs, the Canadian Hydroponic Association. They're out east, and Mackenzie is a really big proponent into this hydroponic farming and growing locally. He's going to touch base on what they're doing and what their organization and association wants to achieve over the next few years here. And then we have Sylvain Goudreau. He's one of our first people we ever actually gave a light to about 6 years ago. He's over in Quebec, and he's going to also talk about mastering the light cycle more conducive to the cannabis industry. He's got some practical methods for improving light distribution and growth efficiency. So again, thank you everybody for joining us here today. This is our first in what we hope to have many more, maybe even one a week we'll strive for. But much appreciated. If you have any feedback, don't be afraid to let us know, because that's how we grow. At the end of the day, Saeid, I'll let you get back home. It looks like it's some bad weather here. I don't know about where you are, but we appreciate everything, Saeid.
No problem. Take care, everybody.
Take care. Bye, everybody.